Hi guys, hope you all had a great midterm. You all enjoyed your week off. This is week 6 that we haven't been in school, so week 7 if you include the midterm. And it's looking like it's going to be another week or two. So I suppose our only option is to just keep going, and as we said before, try and get the theory done. And there's only a couple more bits, to be honest with you. Now, if this keeps going on a bit longer, I'm going to run out of ideas because we're kind of coming to the end of the theory stuff, because usually those topics are mostly experiments, so you'd be doing loads of work in the lab, and it'd be all project based and stuff like that, which is impossible here because we haven't got chemicals and equipment and stuff like that. So we're going to keep going, and we're going to do one small thing today. I'm not going to put you under too much pressure today at all. So about a 20-minute lesson on metals and non-metals, and then going on to a couple of questions which will take you no time at all. So you'll have it all done within the hour easily. And then later in the week we're going to go back to the periodic table for our live lesson later in the week, and then next week we'll do something else theory based, and we're going to start then our end of year project as well, so our Sci-Fest project. So I'm going to put you into groups and do breakout rooms, things like that, to get us ready for that. So we'll go back to the OneNote and get this little add-on out of the way. It's a small little topic called metals and non-metals, and I'll give you the couple of questions for it. And then we'll chat about this later on in the week in our live class, and do another little bit in the periodic table from where we left off before the break. Okay, right, go back to the OneNote then. So, this is it here. Metals and non-metals. So basically things that are metal and things that aren't metal. And we'll have a look at what kind of things they have in common. You can probably, you know the word metal, you know, you probably list for me a couple of metals, and some of them are metals that we make, that humans put together and make things like, you might have heard the word alloy before, you might have heard the word steel before, which is a metal, but it's not on the periodic table, which means it's not an element. So we're just going to kind of clear up the difference between a metal and a non-metal, and a metal that is made and a metal that's an element. So if we think of things that have metals in them, things like metals in our phones, your boiler, your piping, your radiators, all of different types of metal in them. Things that, like your cooking utensils, your spatula and your spoons, and would have different types of metal in them. Some of them heat up, some of them don't heat up. So they have different types of properties. And obviously, if you're building an old house or a building, you're probably going to use a bit of metal to hold the thing up. For a reason. Well, why would you use metal? Why not use straw? Why not use plastic? There's reasons we use metals, and sometimes we don't. Sometimes we don't use metals. And they have a number of things in common, right? So things you think of, well, what do metals have in common? I'm going to go for the easy ones first, and then kind of throw in these fancy science words in a minute. So metals generally are strong. So if you want to build a bridge, you're not going to build it like the taper bridges we built before the break. Remember, we built those bridges and you were putting weights on them. You're not going to put many cars across them because they'd fall through the bridge. So you're going to use things like metal because number one, metals are generally strong. The one very close to that, they're also very heavy. And they're heavy because they have high density. So they're dense and heavy. This thing here about conduction, so maybe that they allow things to travel through them. So metals are good conductors of heat. Heat can pass through them. That's why if you get your spoon, you dip it into your soup and you stir your soup, and you leave the soup sitting there for a while, and you leave the spoon sitting in the soup, and you come back and you touch the handle, even though the handle hasn't been sitting in the soup, the handle is very hot. Also, good conductors of electricity. They're good conductors of heat and good conductors of electricity. So electricity can pass through them really easily, and heat can pass through them really easily. They have high melting points and high boiling points. So if you want to melt a metal, you're going to have to use a lot of heat to melt it down. So if I wanted to melt down the legs of the desk, a Bunsen burner is not going to cut the mustard there. It's going to have to be something that heats it really, really hot. And if I want to turn a metal into a gas, well, I'm going to have to boil that at extremely hot temperature. It's not going to be like water, where you can boil it to 100 degrees and it turns into a gas. Now, so they're the kind of thing. They're strong, they're heavy, they have high melting points and boiling points, and they conduct heat and electricity really well. Now, these three are a different level altogether. These are words that we haven't heard before, but you know what they mean, even though they've put these fancy science words. So We have 3 words to remember, 3 key words. Number 1 is lustrous, 2 is ductile, and 3 is malleable. If you think of the word malleable, it means you can beat them into shape. So if I pick up a metal bar and a hammer and I bash the hammer off the metal bar, it will change shape. It will bend. Quite difficult, but they will. I can bash them into shape if I want. That's what malleable means. Things like a car. You don't want a car that's a big block of metal, like a square. So the shape of a car, that fancy front, the bonnet on a BMW, has to be beaten into shape. And that's done with a specific machine that bashes it into shape. That's what malleable means. Ductile, the second one up there, means it can be stretched. So you can stretch a bar or a rod into a wire. So things like your charger for your phone, it's a really thin piece of copper surrounded by rubber. And so what's happened there is they had a piece of copper and they pulled, and what happens is the metal was stretched into that thin wire. So that's what ductile means. Ductile means it can be stretched. So malleable, you can bash it into shape. Ductile means it can be stretched. So your example of ductile is your wires that carry electricity. And they carry electricity into your house, around your house, through your chargers, through your plugs into your kettle, the whole lot. And the last one, lustrous. Lustrous is a fancy name for shiny. Metals are shiny. Things like your gold jewellery, your platinum, your palladium engagement rings, wedding rings, necklaces, earrings, all of those things make them shiny. So things like mirrors, antiques, jewellery are all lustrous. So there's your 3 fancy words. So your ones you're going to know, things like strong, high melting point, good conductors, good of heat and electricity. You might know from just from using metals, but these fancy words you got to learn: lustrous, ductile, and malleable. Okay, so shiny, stretchy, and you can beat it into shape. They're your 3 words. A couple of things that don't have those. You might have heard of this in thermometers. Mercury. So mercury in your thermometer is actually a liquid at room temperature. So you have to actually put it in the freezer in order to turn it into a solid, but it's a liquid at room temperature. I'm going to talk about these a bit more. Group 1, alkali metals are soft and dense, and I'll show you this in the lab. I'll show you sodium and potassium, your group 1 alkali metals, and you can actually take out a knife and I can cut them. They're quite, they look like a metal, they're shiny. So you'd think it was a metal, but I can take out a knife and cut them because they're actually low density. I can cut off a bit and chuck it into water and show you what happens. Okay, and then we'll move on slightly. This is when we take one metal and we stick it into 1 or 2 other metals. So what we end up with is a mixture of metals. So an alloy is a mixture of metals. And we do that because if a metal is not strong, you want it to be really, really strong, or you don't want it to rust. So stronger to prevent rust. We can get 2 metals, mix them together, and you make something that's much stronger or that won't rust. So we used to have coins made out of things like silver and gold, but we make them of alloys now because they last longer, and they won't break down and tarnish and go all dull on us. That's why your €2 coin is an alloy. Your €1 coin is an alloy, as opposed to being one metal by itself. We need to remember 3 of these here. Okay, so we have 3 different alloys. I would personally pick brass. Nice handy. You've all heard of the word brass before. Used to make musical instruments. And what it's made of, so these are elements here, copper and zinc. So if you add copper and zinc together, you get brass. And that's for musical instruments. Other handy one to remember is bronze. Bronze, you probably heard of that. Statues, bronze statues. The Luke Kelly statue, for example, in town. And the mixture there is copper and tin. So copper and zinc for brass, and copper and tin for bronze. Got to remember that. The other one you've definitely heard of is steel. So steel, things like you've heard of stainless steel cutlery, railway tracks, really, really, really strong. Iron is also really strong, but the problem is iron rusts really badly, so it'll break down if you leave the railway tracks out in the rain, which, you have to leave railway tracks out in the rain because, they're railway tracks. But if you mix iron with carbon, you get steel, and that is much stronger and doesn't rust as easy. Okay, we leave the last one. Solder is an example that some of you might use, especially those who do metalworker technology, because you would use soldering a good bit. But I'm going to give you those three: brass for musical instruments, bronze for statues, and steel for railway tracks. Okay, going away from metals then, I'm going to do it all in the one go. And it's basically the opposite. So if you think of all the properties we gave of metals: lustrous, malleable, ductile, high melting point, high boiling point, conducts electricity, conducts heat, and so on. It's the opposite. If you think, well, non-metals then, well, they're not lustrous, they're not shiny, they're dull. They're not ductile, or they can't be stretched, so they're inelastic, so they don't stretch. They're brittle, as opposed to being strong. They have low melting and boiling points, so basically it's the exact opposite. And they're not good conductors of heat or electricity. So basically, if they ask you in the exam for the properties of non-metals, well, it's the exact opposite of the properties of metals. Okay, and these again, I'd rather be showing you this and doing this with you in the exam and getting you to figure this out for yourselves, to prove that metals are good conductors. So the best way to do it, if you have a battery here, so I give you a battery, I give you a couple of wires, so here's a few wires, I give you a light bulb, and I give you a piece of metal. So I'd be giving you different metals and bits of plastic, and you'd be hooking up the circuit and you'd be telling me, all right, for this piece of plastic the bulb didn't light. Oh, for this piece of aluminium the bulb did light. So a metal will conduct, the bulb will light. Non-metal won't conduct, so the bulb won't light. And that's going to be one of our first experiments that we'll do when we go back. We'll be messing with wires and batteries and figuring out which one's a metal and which one's not a metal. I'll be trying to trick you, giving you ones that look like metals but aren't metals, and you'll be telling me, no, they're not metals because that bulb is not lighting for me. Okay, so that's a great way of figuring out whether something's a metal or not. If the bulb lights, it's conducting, which means it's a metal. If it doesn't, it's not conducting, which means it's not a metal. Okay, the very last thing today, right, is when metals break down. So usually this word here is corrosion is a fancy name for rusting. So rusting is when metal breaks down, and when metal breaks down, it forms this stuff here. So this is a fancy name for rust, iron oxide. So iron, we have iron. If you get rust, you get iron oxide. So that's the nice crossbar of your bike, all nice and shiny. You leave it out in the rain, it rusts, and when you come back, you have a load of iron oxide, which is that brown flaky stuff that we call rust. Okay, so there's your definition. Rusting is a chemical reaction where iron is changed to rust. How do you get around that? How do you stop that from happening? Well, a great way to do it is paint it. Most bikes are painted. And the only bit that actually rusts are the bit that aren't painted, like the chain and the spokes and things like that. So what you get there is you can't get air and water at the metal, so it doesn't rust. So we paint things, we paint our cars, we paint ships, we paint the outside of buildings that are covered in metal to stop them from rusting. One thing you can do if you don't want to paint it, you can do to your chain to stop it from rusting, oil it, bit of oil, bit of grease, and what that'll do is that'll also stop air and water getting at your metal, stop it from rusting. This is a fancy one here, galvanizing. So you can paint it, you can oil it, or what you can do is you can galvanize it. So you can coat it in another metal. So things like your like a bucket, metal sheets that you're going to use in buildings, you can galvanize them. So you're going to cover it in another metal, coating in a different metal. All right, very last thing, right? And then we leave it. So we've metals, we've non-metals, we've how to prevent rusting, and we have properties of plastics. So this is our only thing. So you're dealing with something that's not a metal at all. So most people don't know this, but plastics are made from oil, crude oil, from under the ground. They're great. Isn't plastic fabulous? I know it kind of has people with global warming and climate change don't have an issue with plastic, but you can put it into any shape, sizes, textures, all sorts of things. Everything you think of has plastic in it now. Everything, your food is packaged in, your toys, everything. And plastic is fabulous because you can put it into any shape, any size, different textures. It's easy to maintain. You don't have to paint it. You don't have to put oil. It's not going to rust on you. It's cheap, doesn't cost you anything. It's light, it's not heavy. And what they're great at, they're not good conductors. So electricity's not going to pass through them. But are they brilliant for insulating? So if I gave you your charger and I took the plastic away and you had a metal plug and you had and the rubber was gone off the charger, well, what would happen when you plugged your charger in? You'd hit the roof, wouldn't you? Because you'd electrocute yourself. So what we do is we cover the plug and we cover the wire in a plastic or rubber. And what that does is it allows the charge to get from the wall to your phone without electrocuting you. So it's a good insulator. And you can put it different colours. You can make fancy phone covers, Superman phone covers. You can make all different colour plastics to entertain kids. So they're really, really, really handy. But I suppose the problem is disposing of them. And if we don't recycle them properly, they get into the environment and cause all sorts of problem for lakes and rivers and seas and so on and so forth. But they are phenomenal. Just in case that's asked in the exam, I put it there for you. This is a cool video I want you to have a look at. This is basically what we're going to be doing later in the week. You ever hear of Brainiac? Richard Hammond? And this is again what I'd be showing you with the alkali metals and some of the metals. It's called basically Brainiac, alkali metals. Cool video about how you use alkali metals. And I have these chemicals in the lab that you're going to see them using there. So have a quick look at that. And it's basically blown up stuff using chemicals, and we'll do the same thing. We'll bring a load of it outside into basins of water and chuck it in and see these kind of reactions happening. All I want for you to do, and again we're for the next day, I want these in the homework section of your OneNote. These are going to take you no time whatsoever. What I would do is I would copy everything below here into the homework section and just use your finger to mark in the answers. So just a couple of questions on rusting, on one of the alloys, on a couple of the properties of metal, a bit about plastics, physical reactions and chemical reactions, and a bit about metals, non-metals, alloys, and so on. So it's a mixture of simple questions. It's just a tick box. You're talking 5-6 minutes worth of work. So here's the instructions here, and this is in the OneNote as well. Copy them into your homework section of your OneNote and fill in the answers there as well. So just copy in the answers and shade in the box that's correct. If you can't do that, just write the answers into your homework copy and paste a picture of that into the homework section. Make sure you do that, because that's my only way of taking a roll to see who is engaging with the lessons, if the homework is there in the folder. Okay, well listen guys, have a great week. I'm on email, or you can put a message in the Schoology group if you need a hand with anything or you have a question. That's no problem whatsoever. And I will talk to you later on the week at our live class. Thanks, bye bye.